addressing mode. As the name is port addressing mode, it is for input and output via port. For example, if you want to enter some data into the microprocessor from outward, from any port, you can use this mode. Or if you want to send some data towards the port, then you can use this mode. There are two categories of port addressing modes, and these are the direct port addressing mode and the indirect port addressing mode. In the direct port addressing mode, the address is immediately part of the instruction. For example, you can see over here, it is in AL, comma 02. 02 is address, that is the port address, and AL is your destination where you want to move your data. So what this instruction will do, this instruction will take data from port 02 and will send it to AL. This is called the direct port addressing because the port address is directly part of the instruction. So that you can use for addressing maximum of 256 ports. Because here you can have an address, an 8-bit address, and 2 power 8 is equal to 256. So if you want to address more than 256 ports, then you need to adopt the indirect port addressing mode, because in 8 bits you cannot address more than 256 ports. For that purpose, what you will do, instead of having the direct address over here, you will keep some register over here, and in that register you will keep the address, and from that address would be the port address. So the port address would be put inside a register, and the register would be working as operand in your instruction. So if you do like this, then you can have a 16-bit register for this purpose, and for this purpose we use the DX. So because the DX is 16-bit register, in DX we can put 16-bit address. If you have 16-bit address, then 2 power 16 is equal to 64 kilo ports. So it means that if you adopt the indirect port addressing, then maximum of 64 kilo ports you can address. The Scientix is given over here. It is in AX, comma DX. So what you will put inside the DX, before writing this instruction, you will move the address of the port in the DX, and after that you will write this instruction, and when you execute this instruction, whatever the contents of the DX is, it would be considered as the port address, and for that port, from that port you will get data and you will move that data inside AX. So for example, example is given over here. Suppose that dx is equal to 0, 0, 2, 0. It means what? That the 0, 0, 2, 0 is your port address. And on that location, what is there, or you can say that what is on the port, which data is on the port. If the data on this port is 02, we remember here 20, that is 0020 is the address, and the data on the port is 02 in hexadecimal, and the data on port 0021 is 03. Then after executing this instruction, first the microprocessor will take data from port number 0020, that would be 02. It will put it inside AL, and then it will do increment in this address. So if you do one increment in this address into 0020, it will become 0021. I mean, it will become this address. And then from this address, suppose on this address you have a 03, that is your data. So then after increment, after one increment in this address, from the next address, it will take the data, 1 byte of data, and then the microprocessor will put the data inside AH. We remember AX is the combination of what? Of AL and AH. So from the first address, the microprocessor will take data from the first port that over here, whatever address. So here the address is 0020. So the microprocessor will take data, 1 byte of data from port number 0020, that is 02. It will put inside the AL in the first part of the AX. Then for the next part of the AX, that is AH, it will do increment in the same address, and then from that address it will take the next byte of data and microprocessor will put it inside the AH. So by this way, after executing this instruction, the contents of AX would be 0302. 03 is the AH part and 02 is the AL part. Similarly, in AL, comma DX is used to move a single byte from port address DX to AL. So here the destination is the destination operand is for 1 byte of data, because AL can just contain 1 byte of data. So from this address, you will take 1 byte of data from port and you will directly put it inside the AL. So this instruction will not do increment in the port address, because there is no need, because the destination by itself is of 1 byte. So these are two varieties. I'm going to repeat. There are two types of port addressing modes. Number one is direct port addressing. Number two is indirect port addressing. In direct port addressing, the address would be immediately part of the instruction. And if it is immediately part of the instruction, you can only have 8 bits of address, or in other words, 1 byte of address. If you have 8 bits of address, then 2 power 8 is equal to 256. It means you can only address 256 ports using this method. The syntax is given in AL, comma, the address, the 8-bit address. So according to this syntax, this is your source and this one is your destination. Your source is port. So this is port address. From this port address, the microprocessor will take data and microprocessor will move that 1 byte of data into AL. So this is what this is about the direct port addressing. So if I want to address more than 256 ports, or if the port address is more than 8 bits, then I cannot contain it directly inside the instruction. For that, I will need another register where I will put my address, and that register would be used as an address inside the port addressing. That type of port addressing is called the indirect port addressing. So for that purpose, what we use DX for keeping the address of the port. Be remember, if you want to have a port number more than 8 bits, a port address more than 8 bits can be contained inside the DX register. So, for example, I put my port address, which is 0020, inside the DX. And if I execute this instruction, the microprocessor will take the port address from the DX, and it will, utilizing this address, it will take data from the port and it will put this inside AX. But here, the problem is that AX is 16-bit register, and your port can provide 1 byte of data at a time. So what the microprocessor will do, from the initial address as addressed by the DX, it will take data from one port and it will move that data inside the AL. Then microprocessor will do increment in that address which is provided by AX, and from the next port it will take another byte of data, it will put inside the AH. So by this means 2 bytes of data can be taken from the 2 ports, but the address would be given for the first port. After increment, you will get the address of the second port as well. But if you have the 8-bit register in the destination, then what the microprocessor will do, it will directly use the DX register as an address register, and from that port address, it will take 1 byte of data and put inside the AL.